Hello, welcome to this edition of Momentum. I'm your host, Robert Green. Happy today to have in the studio with me Dr. Craig Merrett. Dr. Merrett is the Associate Department Head in the Richard A. Johnson Chair in the Aerospace Engineering Department, where he also serves as the Associate Department Head.
Thank you.
Dr. Merrett, welcome.
Thank you.
Glad to have you here.
Thanks for the invitation.
Let's start off and say, well, you're from Canada.
Yes, that's
correct. So you were educated in Canada and came here as a faculty member. Yep. Just out of curiosity, can you tell us a little bit, what are some of the differences between, particularly engineering education, between Canada and the United States?
So part of it's tied to the accreditation boards are slightly different. Right. And one of the big distinctions is the number of lab hours as part of the Canadian program is higher than in the American program. So we have more hands-on activities. The other change is what American students encounter during the sophomore year of the program, that's more like the Canadian freshman year.
Okay.
And that has a consequence for the equivalent senior level courses.
So is that due to differences sort of in the K through 12 system?
Yeah, there's a connection there. Yeah.
Okay. Well, you obviously chose aerospace engineering as your major.
Yes, I did.
What possessed you to do that over some of the others?
I grew up watching Star Trek: The Next Generation.
Okay.
And I was like, I want to build the Enterprise. As I got older, I realized, okay, we don't have warp technology, but aerospace is as close as we have right now, so chose aerospace.
We won't get into the original series or Next Generation debate, but I grew up on the original series.
Oh, okay.
Yeah, so, well, we're glad you're here. Did you consider any other majors, or was it just always, ever since Star Trek, you want to do aero?
Other majors within engineering came to mind. Like my dad's a chemical engineer, my grandfather was a mining engineer, so other types of engineering were appealing, but Enterprise, Star Trek, that really pulled me towards aerospace.
Okay. So, but obviously you're a professor here,
yes.
So went to graduate school. Mm-hmm. When did you decide you were going to go to graduate school?
So the decision for graduate school came up while I was an undergraduate student because I had summer internships, and my supervisors strongly encouraged me to pursue a master's degree because to really advance in the field, a master's degree is beneficial. And I applied to a number of universities in Canada and the US. University of Illinois at Urbana-Champaign was very attractive. I met a great individual there, Dr. Harry Hilton, who became my supervisor, did the master's degree, and decided to stay to do the PhD.
Okay. So what sort of preparation did you do for graduate school?
So part of the preparation was taking additional technical electives during my senior year to help prepare for the breadth and depth of graduate studies. Also researching different areas that I might want to focus on. That was spurred by conversations with my undergraduate professors about what they thought would be the leading problems over the next 10 to 15 years, and just looking through the American Institute for Aeronautics and Astronautics publications about what are the trends in the market.
Yeah, okay. So what advice do you have any for undergraduates now that might be thinking about grad school, or maybe for those who aren't thinking about grad school that would encourage them to think about it?
Right. Well, the advice I have for them is, one, there's a big advantage to going to graduate school and going into industry. The simplest one is the pay. There's a significant pay jump. And quite often, the number of years you spend in grad school count for even more years to the employer, so you progress up the career ladder a little bit faster. The other advice I give the graduate student, or undergraduate students considering graduate studies, is aerospace is a very broad field. Now, usually students get into aerospace because they're interested in a particular specialty. Graduate school will enable them to pursue that specialty, so more in structures or propulsion or space flight.
Yeah. So pursuing that specialty, of course, is one reason. And then the hallmark of getting a PhD is conducting original research.
Yes.
So tell us some about the research you did.
During my graduate studies or do
Both,
right now?
both, yeah.
All right. So my graduate studies was about aeroviscoelasticity. So that's the interaction between an airflow over a structure built out of a composite material. Viscoelastic materials are time dependent, and a good example is a memory foam mattress where you press into it, let your hand go, there's the handprint that slowly disappears. So as an airplane's flying, that memory is accumulating in the structure and can alter its behavior over the about 25 years that a commercial airplane is in use.
Yeah.
My current research is still very much viscoelastic related, but it's moved more towards space flight, and the use of composite materials in satellite structures, pressure vessels to maintain rocket motors, and even solid rocket propellant has viscoelastic properties. And the concern now is how do you predict fracture and failure? So that's where my current research is going.
Okay. So that sounds really interesting. What brought you to Mississippi State, though? After all of that, why'd you come to MSU?
Well, a number of reasons. The first was since UIUC was an R1, and I sort of grew up academically in an R1, I wanted to return to working in an R1 university. Just prior to joining MSU, I was at Clarkson University in upstate New York, a small private university. So coming to an R1, and particularly one with such a distinguished aerospace program that's been around for 90 years, there's a lot of legacy there that's I can contribute to the growth of that department and have its facilities help grow my research. So it's a very symbiotic kind of relationship.
Okay. So I know one of your passions is museums.
Yes.
And you got involved trying to get museums more involved in aerospace education back in COVID.
Yes.
Tell us a little bit about what you did and what your plans are for that.
So at the time, COVID sent all the students home. We had to come up with a new way to connect with the students and help them connect both to each other, to the instructor, and to the material. At that time period is around the 75th anniversary of the end of the Second World War. A lot of museums had planned major celebrations that unfortunately were canceled. So I put two and two together with some inspiration from the American Society for Engineering Education and started this project where students connected via Zoom with museums and analyzed parts of their aircraft. And that collaboration has continued and grown over the last few years. There's now about 24 museums that have participated. Currently, I'm trying to include it in the courses I teach at MSU and how we can really advance the state of aerospace education.
Okay, that sounds interesting. I'm looking forward to seeing where that goes.
Yes.
Another thing that you and I both are involved in, and you've sort of taken over since you got here, is the Order of the Engineer,
Yes.
which of course is modeled after the ritual of the calling of an engineer in Canada. Yeah. Tell us a little bit about the Order of the Engineer, what it is, why would students be interested in it?
So I like to liken the Order of the Engineer to the Hippocratic Oath that doctors take. So graduating engineering students can participate in the ceremony where they receive their engineering ring, and it reminds them of their obligation to public safety. And that ring is a daily reminder as they work about what they should pay attention to in terms of the safety and contributing to the public and making sure that all of our engineered products are safe to use, are economically affordable, and environmentally friendly.
Okay. So what are the steps for a student that might be interested in that? What do they have to do to get involved?
So the first step is respond to the registration email that hopefully we'll be sending out soon. Like we do this around the middle of each semester. Once the students are registered, there's a ceremony that occurs near the end of the semester where they will take the oath. And it's a public oath, so visitors are welcome. They do this in front of all their classmates. They receive their ring and sign their certificate that confirms that they are an obligated engineer. Yeah. And then they go out into the workforce.
And then no more meetings after that?
No more meetings after that.
They're not signing up for a lifetime
Nope.
commitment to meet or anything?
Yep.
Okay. We have a lot of unique facilities and capabilities here
Yes.
at Mississippi State, both within the Aero Engineering Department, Aerospace Engineering Department, the Bagley College, and the university. We've got the Raspet Flight Research Lab, the High Performance Computing Collaboratory, Advanced Composites Institute, Center for Advanced Vehicular Systems, and others. How does all that fit in with engineering education and what we're doing here?
So it fits in a lot of ways.
Yeah.
I've been very impressed since my arrival about the number of activities that each of those centers participates in that provides opportunities for both the aerospace engineering students and students in other majors. So as an example, Advanced Composite Institute provides a lot of training related to manufacture of more sophisticated composite systems that are much closer to what's used in industry. So that provides the students with a lot of hands-on learning and a skill set that is helpful for their future employment and excites them about what you can build with composite materials.
Yeah. So I know people look at aerospace engineering and a lot of times they'll think, well, that's sort of fairly narrow. I can only do airplanes or spaceships. But it's really broader than
Yes.
that. Give us an idea of sort of what a graduate from the Aerospace Engineering Department might do. What sort of jobs might they get? Where are they going?
Okay. All right, so there are a lot of jobs. To give you a sense, our professional body, AIAA, has 75 different technical committees, and each of those represents a different area where someone could go work. So it's everything from small satellites, electric propulsion, conventional gas turbine engines, structures, so that's my specialty, materials, aerodynamics, and the jobs where the students can go, there's the traditional employers like Lockheed Martin, Northrop Grumman. There are some of the new employers like SpaceX, Beta Technologies for advanced air mobility, rotorcraft employers like Bell Helicopters, and even engine manufacturers like General Electric.
Okay. Well, we got a little less than a minute left, so let's see how much we can get into that time. We've got some really great student organizations and competition teams, Space Cowboys, Team Exhibitor. We got a group working on CubeSat.
Yes.
Tell us real quickly a little bit about those and how students might get involved.
All right. So each of those student organizations accepts students from all year levels and all majors. So it's not just aerospace engineering students. If you're interested in building rockets, so that's the Space Cowboy team, which won the major international rocketry competition this year.
Yeah, they did 30,000 feet or close to it.
Yes.
Yeah.
If you're interested in unmanned aerial vehicles, so that's Team Exhibitor, they participate in a very interesting competition about tracking and finding targets and delivering supplies to those targets.
Okay.
And then CubeSat, if you want to build something that goes into space, that's CubeSat.
Hope to actually be able to launch that at some point in the future. Well, Dr. Merrett, thanks for joining us. Sounds like there's a lot going on in the Aerospace Engineering Department and a lot for our students to be involved in. I want to thank you for joining us, and I look forward to seeing you next time on the next edition of Momentum.